Hello to all. Welcome to Mathematics Catalyst. After the completion of two videos, one is Introduction to Statistics and one is based on the data, collection of data and presentation of data. After that, we are pursuing with the frequency distribution. Before the frequency distribution, we have the variables. These are the statistical variable. What are the statistical variable? Discrete variable. There are two kind of variables. One is discrete variable. Discrete variable is all the possible integral values within given interval. Suppose there is an interval which is going from 5 to 10. So how many integral values are there? That is 5, 6, 7, 8, 9, 10. है ना? So all the possible integral values with a given interval is called the discrete variable. And here are the some examples which are discussed below. Number of missed calls on the telephone, number of accidents in 1 month, number of students passed in the mathematics, all can be represented with the help of integral only, integers only. And after that, continuous variable. What is continuous variable? The integral and the fractional values are considered as the continuous variable. Like height of the students in a class. Suppose we are talking about the height of the students, as the height of the student may be taken in the case of inches, or you can take into the form of meter and centimeter. So you have to represent the meter by the integral part, and centimeter is in the form of point. After that, weight of the girls in the group. So you are measuring the weight in with respect to the kilograms, है ना, और kilograms और point में आप grams भी ले सकते हैं. So weight of the girls in a group and age of the students in a particular class, it can represent in the form of years, months, and basically days and hours or anything. The age of the students in particular class also represent in the form of fractions. So all the integral values, including the fractional values, are called continuous variable. Okay, so there are the we have to see in the statistics there are two kind of distributions. One is discrete distribution and another is continuous distribution. So for those distributions we have to consider these two type of variables. After that, frequency distribution. What is frequency distribution? Basically, frequency distribution is the distribution which is with respect to the frequency. We have to take the distribution with respect to the frequency. Frequency is also called the barambarta in Hindi. So barambarta bantan means frequency distribution. So in case of frequency distribution, basically there are four kind of distributions. One is array. First is array distribution, right? So in case of array distribution, the set of the series of individuals either in the form of organized or unorganized form is called array or array data. मतलब you have to arrange the data in the form of numbers only. Like 20 students scored marks out of 100 in the statistics, and there are 20, 35, 40, 35, 60, 40, and these are the marks obtained by the students, and these marks are not given in the ordered form, right? So it may be in organized form or unorganized form. So such kind of distribution is called array. Second is discrete or discrete. I have told about the discrete also. Discrete or ungrouped frequency distribution. The array data which can be expressed as tabulated form. Matlab we have to convert this data into the tabulated form, right? This tabulated form. So we are observing that here 20 comes how many times? So whenever you see the data here, so 20 comes one time only, right? So you have to see this is coming one time, and after that, that is 23 how many times are there? When you check here, it is 23, and here is also 23. So 23 here 2 times, right? इसी तरीके से 34 जो है, that is also 2 times, and 35 you can observe it also 2 times, and 45 is also 4 times. You can see here 45, and it is also 45, and it is also 45, and this is basically it is 4 times, right? This is also 4th time. So in this way you can organize the data in the ungrouped frequency distribution or discrete distribution, right? And after that, frequency distribution में third kind जो हमारी है वो कौन सी है? That is grouped frequency distribution. Now what is the group frequency distribution, the classification of the data in different classes by dividing the entire range of variable into the specific number of groups. मतलब आप क्या करेंगे, you have to make the groups like those students who are scoring the marks between 10 to 20, those students who are scoring the marks from 20 to 30, है ना. इस तरीके से अगर आप डाटा को बनाएंगे तो उस डाटा को हम बोलते हैं ग्रुप फ्रीक्वेंसी डिस्ट्रीब्यूशन एज पर फ्रीक्वेंसी ऑफ द वेरिएबल्स रिकॉर्डेड, right? After that, continuous frequency distribution, group frequency distribution, another is continuous frequency distribution. It is also a kind of the group frequency distribution, but classified groups are based on the continuous variable. I have told about the continuous as well as discrete variable. So basically there is a main difference in these two kind. In group frequency distribution we have the discrete distribution, and in case of continuous frequency distribution we have the continuous variables. Okay, and as but we can leave the undesirable values. Suppose we don't need some of the values, so you can reject those values in case of continuous frequency distribution. After that, there are two kind of continuous frequency distribution. One is inclusive and another is exclusive distribution. So whenever we have the data in the inclusive data type, so what is inclusive data type? The classes of the type 10 to 19, 20 to 29, 30 to 39, means you can see here the upper limit of this is 19 and the lower limit of this class is 20, right? So whenever you take the second class, so its upper limit is different from the lower limit of the previous class, right? So in such kind of data are called inclusive data type, in which both upper and lower limits are included in the class, is called the inclusive frequency distribution. What does it mean? It means whenever you take consider the data, then you have to take both the consideration, like you have to count the 10 as well as 19 both, and all the numbers which are lying between 10 and 19 वो आपको सारे के सारे number count करने हैं. तो such kind of information is collected in the inclusive data type. And another is exclusive data type. What is exclusive? The classes of the type 10 to 20, 20 to 30, and here you can observe that the upper limit of the first class is equals to the lower limit of the second class, right? So in such type of distribution is known as the exclusive data type, in which lower limit is included. एक चीज और नोट करेंगे प्लीज, lower limit is included but upper limit exempted from the data is called the exclusive frequency distribution. Means whenever you count the numbers, then you can leave the 20 in the first class, right? After that you can leave 30 in the second class, you can leave 40 in the third class. So upper limit you can leave, but lower limit you must include in the data. Such kind of data are called exclusive data type. So basically we have to convert the inclusive data type into the exclusive data type. When you do any statistical problem, you have to convert the inclusive data type into the exclusive data type, then solve the question, like you have to find the mean, mod, median. In all these statistical informations, we need to convert the data into the exclusive form first, right? After that, what are the class limits, boundaries, class boundaries, and class marks? There is very little difference in all these things, but they are different basically, right? So first is here we can see it is the inclusive data type. So 10 to 19, in this case 10 is the lower limit, right? 10 is the lower limit and 19 is the upper limit. We are distributing here upper and the lower class limits. So here 10 is the lower limit, 19 is the upper limit. In the second class 20 to 29, we have 20 as the lower limit and 29 as the upper limit. Similarly, for the other class 40 and 49, we have 40 as the lower limit and 49 as the upper limit. And what is D? What is D? What is D? D is the difference between these two values. You can see here we are taking the upper class upper limit, है ना, और जो second class है उसकी हमने क्या ली, lower limit ली, and subtracting both. तो 20 minus 19 becomes 1. Similarly, you can take these two classes also. In these two classes 40 minus 39 becomes 1. So it must be homogeneous. The value of D must be homogeneous, and D by 2 becomes 0.5. Then what are the upper class boundaries? Basically I was telling you about D because we need to find out the upper class boundary limits, which is dependent on the concept D. So upper class boundary is 19 plus 0.5, which thing you have told here, D by 2 is 0.5. You had to add the 0.5 into the 19. What is 19? 19 is the upper limit only, upper class limit. तो upper class limit में 0.5 को add करेंगे, that is 19.5. and lower class boundary क्या होती है, जो lower limit है उसमें से आप क्या करेंगे, you have to subtract 0.5 to get the 9.5. तो what is the difference between the upper class boundary and upper class limit? Upper class limit is nothing but it is the upper limit of each class, right? And but upper class boundary limit is whenever you add the upper limit into the D by 2. Upper limit plus D by 2 becomes the upper class boundary. Similarly, lower class boundary limits is lower limit में से you have to subtract D by 2, we get 9.5. Next is class marks or mid values. What is the class marks and mid values? Class marks आपका होता है LCL plus UCL, मतलब upper class limit plus lower class limit dividing by 2. You have to take the midpoint of lower class limit and upper class limit. We can take this exclusive distribution or inclusive distribution. Whenever you convert this distribution into this form, it's okay, है ना, by taking the lower class boundary limit and upper class boundary limit. Or otherwise, if you are not converting it into this form, then the LCL plus UCL dividing by 2 is same as upper limit plus lower limit dividing by 2. Means you have to take 10 plus 19 upon 2, or you can take 9.5 plus 19.5 upon 2. We get the same value, 14.5. So mid value can be defined as the midpoint of the upper limit and lower limit, or you can say it is a midpoint of the lower class boundary limit and upper class boundary limit. ठीक है, in this way we can define the mid value, or you can say it is a class marks. Next is cumulative frequency distribution. What is cumulative frequency distribution? In the cumulative frequency, cumulative means you have to add, commute, right? Cumulative means you have to add all the informations. The modification of the frequency distribution on the successive addition of the values of the class or variable as per requirement, either less than or more than. Basically, cumulative distribution is of two kinds. One is less than distribution, another is more than cumulative distribution. How to find these kind of distribution? Suppose we have here some example of exclusive data type, 35 to 45 in mathematics. There are the marks distribution is given and number of students are 5, and 45 to 55, that is 10 number of students, and 55 to 65, here are 15 students, and 65 to 75, 30 students. In this way we can observe the data. This is the exclusive type data. Now we want to find out the cumulative frequency distribution in case of less than and more than distribution. So here, what is less than distribution? Cumulative distribution. In less than distribution we can observe easily that in less than distribution we can easily observe that 35 to 45 was frequency 5. Now less than 45 means less than 45 you have to take the upper limit, right? less than 45 कितने होंगे आपके? 5 होंगे. अगर मैं बात करता हूं less than 55 के लिए आप क्या करेंगे? You have to commute both, you have to add both 5 and 10. 5 and 10 becomes 15, right? उसके बाद less than 65 का मतलब क्या होगा? less than 65 means you have to add all the information above 65, that is 5 plus 10 plus 15, that becomes 30. And less than 75, what is the meaning of less than 75? You have to add all these informations, so 5, 10, 15 and 30, that becomes 60. And less than 85 means you have to add all these informations from this to this, that is 65. And less than 95 is you have to add all the information from top to bottom, that is 70. So in this way we can find the less than distribution. Similarly, we can go for the more than distribution. In this we have to take the lower limit, right? So greater than 35 are 70, because in greater than 35 we have to take all these values, right? All these values, that is 70, right? क्योंकि total frequency कितनी हमारे पास, that is 70. And if you are taking more than 45, so more than 45 means you have to take 10 onwards. If more than 55, in more than 55 you have to take more than these values, right? In case of more than 65, you can observe these are greater than 30, and in case of more than 75 we have these, only these two values, 10, and more than 85 is here 5 only. So in this way we can fill this distribution less than cumulative distribution. That is more than cumulative distribution, it is not less than, please, more than cumulative distribution. So in this way we can define the cumulative distribution. And now last is bivariate frequency distribution. What is bivariate frequency distribution? Bi means 2, right? Sorry, what is bivariate frequency distribution? Bi means 2, variate means variables, frequency you know बारंबारता, and distribution is बंटन. इसका मतलब bivariate frequency distribution implies the two variables distribution. मतलब here we have the row wise distribution, that is x1, x2, x3, xm, and y is the another variable which we are taking in vertical sense, y1, y2, y3, ym, right? And this is we are taking in horizontal sense. So x you are taking in horizontal sense and y is in the vertical form. Whenever we need to write the value f of x2 y2, so f of x2 y2 will be the position of here. You can draw from this x2 and y2, so this will be the position x2 y2. So whenever you fill this whole data, so this will be right. If you want xm, you need the value y3 and x4. So x4 means this value, right? And y3 is this value. So this is our intersection point. So here we should write f of x4 y3. F means frequency here. So frequency means we have to take the frequency with respect to the two variables. So it is called bivariate with respect to the x as well as y. And here we have the frequencies of y, means total frequency of y series in vertical sense, right? In this way we have to write the total frequency with respect to y, and here total frequency distribution, here total distribution fx means total frequency of x series, और यहाँ पर जो होगा that is the total of fx and fy. So in this type of distribution you can say it is a bivariate frequency distribution. Then finally we can say the bivariate frequency distribution has row wise x variable, column wise y variable, and there is the frequency with respect to x and y variable data, and this is the total frequency for x series, there is the total frequency for y series, and here we have the total of everything, right? So after completing this bivariate frequency distribution, finally we want to say that you have to use this statistics lectures on the regular basis, as it is very important part in our modern sciences nowadays. So if you don't like the phase of uncertainty in your life, then kindly love statistics. Thank you.